Greetings and welcome to your algebra recording for the week. We are in week 9. It's the week of March 7th through March 13th. And this week we are going to focus on scatter plots, how we can take a scatter plot and look at it to see the correlation and if there is a causation between the two variables being looked at and analyzed. And then finally, we're going to look at how we can use technology to help us find the equation of the line of best fit. So here's just a little diagram below to show you an example of a scatter plot. The dots here are the line of best fit. So that's what we're going to be taking a look at this week, a little bit more in depth. Just a heads up, this week you will be completing assignments in Schoology and in Edgenuity. So I am going to give you some information about scatter plots and line of best fit in Schoology as well as in Edgenuity. So just a heads up to make sure that you are going through all the folders slide by slide this week, and that way you won't miss any assignments. So remember, when you go into the week 9 folder, just make sure that you are going through the slides one by one so that you don't miss anything this week. All right, so let's jump right in and let's chat about what a scatter plot is. So a scatter plot is a way that we can look for relationships between two sets of data. So we're always going to have an X and Y axis. So here's an example of a scatter plot where we are comparing the variables weight and height. So you're always going to have two sets of data that we're comparing, and then we are going to use dots showing one person's weight versus their height. So each dot represents one person's weight and height. So what we've done here is we've plotted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people's height and weight. So each dot represents somebody's both their weight and height. So this is an example of what a scatter plot will look like when it's done, a bunch of dots. And we can look at these dots to see if there's a relationship between the two sets of data. And in this scatter plot, we can kind of see that there tends to be this relationship that as the weight is increasing, so is the height. So those are the types of relationships that we look for to see if they exist. Sometimes there is no relationship that exists between the two sets of data, and we're going to chat more about that right now. So I'm going to go on the next slide, so if you need more time, go ahead and click pause so that you can take good notes. Remember, you should be taking notes today. So scatter plots, what do they show us? So scatter plots are especially useful when there's a large number of data points, because it helps us look to see if there's a relationship. It gives us a good visual if there's a relationship between the two variables. So we can look at the scatter plot to see if there's a strength between the two data points, and we're going to talk about this correlation. And we can see really if there's any outliers. So in this one, there doesn't look like this example of a scatter plot. It doesn't look like there's any outliers. An outlier might look like if there's a point up here in the or over here that's not closely located next to all the other data points. So a correlation, and correlation is really what I want to focus on now, this idea of correlation. So a correlation between the variable results in the clustering of data points along a line. So here, see how all of our data points are kind of clustering and they almost look like they're forming a line? And this example of a scatter plot would be suggestive of a positive linear relationship. And when I say positive linear relationship, it means that as one variable increases, the other variable is increasing. And that type of relationship is what we call correlation. And we're going to talk more about that on the next slide here. So correlation, which in math we represent with R. So correlation, when you see an R equals, and you're given a number, that is referring to correlation. So write that down in your math notebook right now. The correlation is represented by R, and it's the relationship between the two sets of data. So let's look at the different types of correlation that we can have. And remember, we're talking about how our points are clustered and if they look like they're clustering in a line or not, and what direction is our line headed in. So here, this first one is a high positive correlation because our line, our points are clustered in what looks like a line, and it's going in a positive direction, meaning that as each axis, the variables increase, the other one would increase as well. So these points are pretty well clustered. Where if we look at the next one right here, this next scatter plot, you can see that our points aren't as tightly packed. They're still showing us that we're going in a positive direction, but our points aren't as tightly clustered. They're not as tightly packed in a as they were here. So this we would call a low positive correlation because the points aren't as tight as they are over here, where this one would be a high positive correlation. And then we can see the opposite below. So let's go in a different color here. So these points, all these, are pretty clustered pretty tightly. But in this case, they're sloping downward, which is telling us that as one variable decreases, the other one is also decreasing. So these, because they're tightly clustered and really do look like they form, they're tightly packed together, this would indicate that it's a high negative correlation. Where over here, when our points aren't as closely clustered together, this would indicate a low, but they are still sloping downward to show a low negative correlation. Sometimes we have it where all of our points are scattered all about and they really don't seem to be directed in either direction. They don't look like they're increasing or decreasing. And we would just call this no correlation. It doesn't really look like there is a pattern rising or falling. So again, you want to look to see if your points tend to be rising or if they tend to be falling. And that's going to tell you if you have positive or negative correlation. And then we want to see how closely they're clustered together. And if they're really closely clustered together, you're going to have high positive or high correlation. And let's go on to the next slide and take a look a little bit further of correlation. Remember, our correlation coefficient is represented by the letter R, and the correlation coefficient is a number that lets us know how well the data set is fit by a model. So it lets us know how well the data is either, does it represent high or low correlation. So if you've got a set of data, I should say that the correlation coefficient can range anywhere from -1 to +1. So that's the number of our correlation coefficient can range anywhere from -1 to +1. So it's got to range anywhere from -1 to +1. So the closer we are to 0, like right in the middle there, if we have a correlation coefficient that's at 0 or close to 0, this represents no correlation. So the closer we are to 0, the weaker our correlation is. The closer we are to -1 or +1, so the closer we are to -1 or +1, we're going to have a stronger correlation, high correlation. We would have high correlation. So if we're close to -1, so here in this diagram, our R is equal to -0.95, that's really close to -1. So if we have a -1, negative means that we're decreasing. So it's close to it would show us a high negative correlation if we've got -1. If we have +1, the opposite is true. We would have high positive correlation. So that would be that +1. And as we get closer to 0, the weaker the correlation gets. The weaker the correlation gets. So you can kind of see that right here in these diagrams. You can see that we've got really tightly packed data points and that they're falling, so it shows negative correlation. So -9.5, that's a pretty high negative correlation. Here our points start to get a little less tightly packed, but we still see that it's falling, it's decreasing. So here our R is equal to -0.6. We're getting closer to 0. If our correlation coefficient is 0, our points are all over the place. There's no correlation. And as we start to work our way back up to +1, we can see that the closer we get to +1, the more tightly our points are and that they're rising. So here's a nice chart down here, probably a good thing to copy down in your math notebook, talking about the strength and direction of the correlation. Our strong correlation is going to be at -1 and +1. Negative correlation at -1, positive at +1. And then we get more weak as we head towards 0, where there's no correlation. All right, I'm going to go to the next slide now. So if you need more time, go ahead and click pause so you can take wonderful notes. All right, so one thing that we can do is we can create a scatter plot, and from our scatter plot, we can use technology to find a line of best fit, but sometimes it's just nice to do a scatter plot to see the trends and what it looks like, and then use technology to find the equation of a line of best fit. And that's what we're going to do. So remember, anytime we talk about linear equations, we're going to use that y equals mx plus b. That is the equation of a linear equation. So just to review, that is what a linear equation looks like, where remember m represents our slope and b represents our y-intercept. So take a moment to write that down in your math notebook and what m represents and what b represents. So go ahead and click pause so that you can write that down in your math notebook. All right, so we've got some data here. We're going to compare our study hours with, let's say, just a test score. We're going to say test scores. We're going to compare and see if there's a relationship between the amount of time spent studying on a test and then the test scores. So we're going to first plot our data and compare this information. So I'm going to do time here, times spent studying, and then the test scores will go over on this axis. And we'll just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the time in hours spent studying and the corresponding test scores. So I think if we go up by 10% each time, that should give us 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And now we can plot our points. So if somebody studied 3 hours and they got an 80% on their test, I'm going to plot that point. And somebody spent 5 hours, somebody who spent 5 hours got 90%. Somebody who spent 2 hours got a 75. Somebody who spent 6 hours got an 80%. And somebody who spent 7 hours got a 90%. And one person who spent 1 hour got a 50%. 1, 2, 3, 4, 5, 6. So we plotted everything. So does it look like there is a trend? It does. It looks like we're going in a positive direction. It looks like it's rising. So there definitely looks like there is a relationship between the amount of time spent studying and the test score. So the more it looks like, and we'll talk about that in a moment here. So we are going to use technology to find a line of best fit. So I'm actually going to use a website to, and this website that I'm going to be using, I do have the link in your lessons this week. So you will see the link in your lessons this week to the website that I'm going to use. So what I've done is I've copied down my study hours and my test scores, and I'm going to copy that into the website, and I'm going to share the website that I'm going to use. So let me get that going for you. So I'm using graphpad.com, and I'm doing a linear regression to find the line of best fit. So I'm looking for the line of an equation. So what I did is it's got this table here where I entered in my x values, which represented the number of hours spent studying, and then the corresponding test scores as my y values. And here it says calculate now, and it's going to have it's going to calculate for me the line of best fit. So here is my slope. So here's my slope, and my slope is 5. So my slope is going to be 5, so I'm going to write that down. I'm going to put m equals 5, and just use slope. Don't worry about that plus or minus. Just use the slope as 5. Don't worry about the plus or minus 1.86. Just use that 5. And then the y-intercept, I'm going to copy that down. It's given to us as 57.5. Don't worry about the plus or minus 8.4. Just copy down that 57.5. And then the other information that I want us to take is so the other thing we want to copy down is that r square equals r squared equals 0.64. So copy down your slope, your y-intercept, and then the r squared. So we're going to write down those values, and we're going to use those values to write the equation of the line of best fit. So we're going to go back to this screen now, and let's copy down the information. So here's m equals 5, because remember m represents slope. B equals 57.5 because B represents my y-intercept. And then we're going to hold on to this r squared. Actually, I could probably put that down here. R squared equals 0.64. And we'll talk about that in a moment. But let's now write our line of best fit. So remember, the equation for a linear equation is y equals mx plus b. So y equals mx plus b. And now we're going to substitute in our values for slope and our y-intercept to get our equation. So it's going to be y equals, our slope is m. So we're going to substitute in 5 for our slope, which we let the calculator figure out for us. And then our y-intercept was 57.5. So this is our equation of our line of best fit. So this equation represents, if we were to put a line that is as close to as many points as we can get it to in our scatter plot, this equation represents this line right here. So y equals 5x plus 57.5. This equation represents this line right here. So our line of best fit is a line that we can get as close to as many points on our scatter plot as possible. And that's what I have it with this light blue here, is a line that's as close to as many of our points that we plotted in our scatter plot. And then this is the equation that represents that line. Now we want to see how close our equation is to all of our points, how well it represents all of our points. And that is what our correlation coefficient is going to tell us, is how close our line of best fit gets to all of our points. So I have r squared and I just want r. So remember, to get r all alone, I need to undo a square. So I'm going to take the square root. So to get just the r value, I'm going to take the square root of 0.64. Now sometimes if you're using like a graphing calculator, it would just give you the r. So look to see if your calculator that you're using gave you r squared or just plain r. If it gave you just plain r, use that value. You don't need to take the square root. So I'm going to take the square root of 0.64 and I get 0.8. So I get 0.8. So what that's telling us is that there's a pretty strong positive correlation. So this is telling us, because our r is 0.8, that there's a high or a strong positive correlation. Really, that's what it's telling us, is that as the more time we spend studying, the higher our test scores. And that is our causation. So our causation is if looking at our, we look at our two data and we see if it makes sense that one variable affects the other. And in this case, it really does. If someone spends more time studying, the higher their test score will be. So I'm going to finish writing that in. So so if someone spends more time studying, the higher their test score. That is the causation. Looking at if there is a relationship that makes sense between the two variables that you compared. So remember, correlation is a little bit different. Correlation is that variable, that r. So correlation is when we look at the r value. And remember, if it's close to 0, there's really no correlation. And if it's close to a positive one, the closer it is, the stronger the high correlation, positive correlation is. And if it's closer to -0, it's a negative correlation. So that's what you're going to do this week, is you're going to look at scatter plots. You're going to look at the correlation between the scatter plot points. And then you're going to use technology. So you will be using technology to find a line of best fit. So remember, to find a line of best fit, you need to know what the line of a linear equation is, which is y equals mx plus b. And you need to know that the m represents your slope and b represents your y-intercept, or where it crosses your y-axis. So in this case, our y-intercept was at 57.5, meaning that somebody who spends 0 hours would get a grade of 57.5. And the slope tells us, our slope of a 5 tells us that each hour somebody increases their time spent studying, that your grade will go up 5%. So that's what that slope of 5 tells us, is that each hour increased hour spent studying, that you would go increase your test score by 5%. And you're going to be asked questions like that this week. When you look at your equation of your line of best fit, do you understand what your slope tells you and what your y-intercept? Remember, your y-intercept is just where you're crossing the y-axis, at what point. And here it was at 57.5. I'm going to stop now, and if you need more time, rewind and take more notes, but I'm going to put up the key phrase assignment. So in today's recording, we chatted about how a line of best fit is a line that we draw in when we have a scatter plot, and we get it as close to as many points as we can possibly get. And then we want to find the equation of that line, and that's what we call the line of best fit equation. So the line of best fit uses a linear equation because it's a line. And we know a linear equation is represented by y equals mx plus b. What you need to do is tell me what the m and the b represent in the linear equation. So what does that m right here and the b represent? If you need a reminder of how to complete the key phrase assignment, the directions are below. Otherwise, have a fantastic rest of your week, and as always, let me know if you have any questions or need any help as you work on this week's assignments.